unijunction transistor or UJT. Welcome to D Creations Resources. Let's talk about unijunction transistor. It's basically a 3-terminal semiconductor device, and as you can see in the name, unijunction. Uni, the meaning is one. So it has only one PN junction. Now when we say one PN junction, I'm sure you must have thought about diode. But UJT is different from an ordinary diode. It has 3 terminals and its behavior is also very different from diode. Now if you want to know the basic construction of UJT, it consists of a N-type silicon semiconductor bar and a P-type silicon region. This N-type bar is called a base and this P-type region is called an emitter. So the PN junction is going to form between the emitter and the base region. Now if you consider the doping, the emitter region is heavily doped while the base region is lightly doped. Because of this, the resistivity of the base material is very high. Now there are 3 terminals which are taken out of the whole structure. One is from the emitter region while the other 2 form the ends of the base region. So one from the emitter region is of course called emitter, while the terminals from the base region can be called base 1 and base 2. Emitter region is closer to base 2 terminal than base 1. So if you now try to imagine, base 2 is on the upper side and closer to emitter, while base 1 is on the lower side. Now what is an equivalent circuit of UJT? It basically contains, you can say, of a diode and a resistance. So the diode is going to represent the PN junction, while the resistance, since it's base to base, you can also denote it as RBB. This resistance is the internal bulk resistance of the silicon bar from one end to the other. Or in other words, it represents the total resistance between the base terminals. Since it is total resistance between the base terminals, it is also called inter-base resistance. You can also write it as sum of 2 separate resistances, namely RB1 and RB2, which basically correspond to 2 bases, in the sense that resistance RB1 will be representing the bulk resistance between the emitter and base 1, while resistance RB2 will be representing the bulk resistance between emitter and base 2. Now of course total resistance RBB is going to be sum of these two. So RBB will be RB1 plus RB2. Now when there is no voltage applied to the UJT, value of the resistance RBB lies typically between 5 to 10 kilowatt. Value of the resistance RB1 varies depending on the emitter current. So it is also denoted as a variable resistance when an equivalent circuit is drawn. And depending on the value of emitter current, the value of this resistance can lie typically from between 4 kilo ohm to 40 ohm. Now there is an important concept called intrinsic standoff ratio. So what is this concept? If you consider an equivalent circuit of a UJT, and if you consider that battery voltage VBB is applied across its base terminals B1 and B2, then as the emitter is open, the applied voltage VBB will divide itself across resistance RB1 and RB2. So what will be the voltage across the resistance RB1? If you denote it as V1, we can say that V1 is equal to RB1 upon RB1 plus RB2, and this whole ratio into VBB. So you can write it as RB1 upon RBB and this whole bracket into VBB. or in other words RB1 into VBB divided by RBB. Now this resistance ratio RB1 upon RBB is called the intrinsic standoff ratio. Now since it's a ratio of two resistances, obviously it's not going to have any unit, and it is usually represented by neta, the symbol. So neta is RB1 upon RBB, which is basically equal to RB1 upon RB1 plus RB2. Now generally the value of intrinsic standoff ratio is between 0.5 to 0.8. And the voltage drop across the resistance RB1 is called intrinsic standoff voltage. So this basically reverse biases the emitter diode.